Hello everyone. So, given we have this array, it's not sorted as you see. So the elements are 1, 2, 5, 6, 4, 5, 7, and the indices are 0, 1, 2, 3, 4, 5, 6. Okay. And given we have a task that we need a pair, two elements of this array, these two elements equals this target, 10, right? So we have to find the pair from this array. What we can do, a simple approach, and it's a brute force approach, is that we start two pointers. Let's say one of them is this one, okay? This pointer will loop through every element in this array, and along with it, we will have another pointer. And what we do, every time we check whether the sum of the values of these two pointers, whether it's the target or not. So for instance, so it will be 1. Then we start this pointer. They should not point to the same index. So for example, like this, and it keeps going. And then when this comes here, this will loop here, and then from here and so on. Like they wouldn't loop in the same element. So for now, it's this. So does the sum of these two elements equals 10? No. Does this sum of these two elements equals 10? No. No, 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 and so on. So we do that, and then we move the I, and we iterate again, and then we move the I, we iterate again. So like 5 plus 1, 6, no, 5 plus 2 here. So 5 plus 2, uh, so 5 plus 1, it's 6, no, then 5 plus 2, 7, no, 5 plus 6, 11, no, it doesn't equal the target. 5 plus 4, 9, it doesn't equal the target. 5 plus 5, it does equal the target. And these are two distinguished elements, of course. It's not the same one. And that's why we need two pointers. Because that's why we need two pointers, and they shouldn't point to the same value. Because otherwise, this here will return 10. But we don't want that. We need a pair of values. So two distinguished values. They should have different indices. Even if the value is the same, we don't care. They should have different indices. So now when our pointers, given this is I and this is j, they both point to 5, and the sum of 5 is 10. Here we stop, and we return 10. We return 5 and then 5, like this. So 5, 5, two values, right? So we return this as the response to this algorithm. But let's say there is another possibility that these two, 6 and 4, they could have been returned. But like we seen, it's sequential, and that's why the way it happened in a linear manner, we figured that 5 are the first sum or the first pair that we could find using this algorithm. There is a different manner. So this manner here, it took us the same space. We didn't allocate any memory. However, what we did allocate is that we needed O of n squared time. O of n squared time. Why? Because like you've seen, we would iterate through every element, and then when we are iterating through those elements, let's say with the I, we then iterate through them again with the j, and that happens for every element. So like I said, that's O of n squared. Now there is a better way. So what we can do instead is we start one single pointer here. Okay, let's call it I. And then what we do is we create a hash table where we store our elements. So we store the key of this hash table will be the value here in this array. And then what we do, on every iteration before we insert it, we calculate whether that's the value we are looking for or not by making use of the 10, the target that it's provided. So the formula would be the diff equals the target minus the element we are pointing to. So now the I is pointing to 1, right? So I will write it this way: array and then I, right? So for now, let's do this. 10, the target we are looking for, minus the value here, which is the like the array at index here that we are pointing to, or using to iterate. So the value will be 1, right? 10 minus 1, it equals 9. Is 9 exists here? No, it doesn't. So what we do, we take the 1, we add it. So 1. We don't care about the value, we just care about the keys for now. Then we do that again. So we bring the I here, it equals 2. So 10, the target, minus the value 2, it equals 8. Do we have here an 8? No, we don't. So what we do, we take the 2, we put it right here, right? Then we do that again. We come to the 5. So 10 minus 5, it equals 5. Do we have 5? We don't. Okay, we continue. Then we come here to the 6. So 10 minus 6, it equals 4. Do we have a 4? No. We have 1, 2, and 5, like we know. We take the 6, we put it here. Then now we move the I again. It shows 4, right? So 10 minus 4, it equals 6. 6, we have it right here. We stop and we return the result. So it's 6 and 4. Right? So, and we didn't even continue to iterate, and this took us much less time, but it took us an additional space, because in the first, so now we did allocate a new memory, and we were putting the elements into this memory, and this is a hash table. So this will take O of n space. So that's an additional, like, because in the first one we didn't take any odd space, we kept just calculating elements from the array. However, now it takes O of n time as well. So the first one took us O of n squared, right? Time. So time, this is the first. And this one took us just O of n, because we would need to iterate just once. As for space, the first one, we didn't use any more space. We didn't use additional space. In this one, we are using a hash table, and that's O of n, where we are going to put all our elements. So that's the other thing to mention, besides the time space complexity. There is the results. There is two different results, because, like I said, the first one was sequential, and whenever it gets to a value, it will iterate through all other values to make sure whether this two values like this pair equals the target we are looking for. As for the second one, we only know about the element we are in and the elements before it. So, when we were here, for example, we didn't knew that there is another 5 or 7, and we don't care if we have another 5 or 7. We just care about the elements before it. And this is, like I said, will save us more time. So let's write that in code.
So we have here the same array. So we have here the same array, as we can see here, 1, 2, 5, 4, like 6, 4, 5, 4, 7, right? The same one here. And we have the two functions. Let's start with the brute force function. For I equals 0, I is less than the length of the array I plus plus, and then for j equals 0, j, then the length of the array j plus plus. What we do, we have now these two iterators, right? The I and the j. like we spoke. Now what we need is the sum. So array I plus array j. If sum equals target, here the value we are providing 10 for instance, and we want to make sure that I does not equal j, right? We don't want to point to the same value, otherwise we are returning just one element, right? So we don't want that. We need them to point to different ones. So now if that's true, we take the result, we create two spaces in our array, result 0 array I, result 1 equals array j, return result, right? Let's run this. Great, 5 and 5 like we saw here, right? Now let's do the other way. Let's do this one with the hash table. So the first one, we create the hash table. Let's create a map. It's called a map in Golang. So map int, right? For I equals 0, I is less than the length of the array, our iterator here, and I plus plus. What we do, we do the formula. The difference equals the target minus the value we find from the array. Now what we do is we check whether our map does have that or not. To do so, in Golang, there is this. You see, we are providing the def as the key, and we are trying to find out whether we do have it or not. This will return the value, but as we don't care about it, we just are going to use this blank identifier, and PRS is going to be a boolean whether we do have it or not. So it's a true or false, right? So if PRS is true, result, we do basically the same here, right? Except here we put the difference, and here we put the I, right? We return them in the same order. So now what we do, if it's not true, then if it's false, if it doesn't exist in our hash table, now our job is to add that value to the hash map, right? So to do so, values array I equals I. I is the value even though we don't care about it. So that's how we are adding the keys in our hash table. I'm calling interchangeably map because it's a map in Golang, but it can be different in other languages. As we see, we have 6 and 4, right? Like we said, if we try any other number, maybe I don't know, like 11, 5, and 6, right? That's 11 in both cases. So that's it. So to write it again, this took us O of n time and O of n space because of this map that we created. This instead did take only time O of n squared because of our 2 times iterating through this array, these 2 lines right here. Okay, so that's it for today. If you are not familiar yet with getting the two sum problem, there is another tutorial. I will put it here in the end of the video when it's a sorted array, because if it's a sorted array, you don't have to go through this. So I will link that in case you would like to watch it. Thanks for watching and see you soon.